We've got Tom Charter from Damen, representing Damen, to talk about electric drive technology for tugs. The future is now. Oh, I need to advance the slide, would help, wouldn't it? There we are. On the page. Right. And I do profess a little bit of interest in this because I have just spent the last 7 years married to my wife still, and she's been working on a PhD on electric vehicles and all the policy implications and what governments should be doing to encourage electric vehicles in the Australian domestic market, which obviously has significant impacts on the greenhouse gases and all sorts of other things. So of course this sort of still another mode of transport that is all going towards the electrification of all our transport needs. So I'll be very interested to see any parallels and contrasts between what I've been living with for the last 7 years and what Damen have been doing in the maritime sphere. So anyway, Tom is the Damen Shipyards representative for Australia, New Zealand and South Pacific, and is responsible for managing the group's representation throughout that region, entailing business development and sales activities. He's also the sale and purchase manager with Australian Independent Shipbrokers, which is operating on a worldwide basis, providing sale, purchase and chartering brokerage services across a range of shipping sectors, with a focus on the offshore support vessel, tug and workboat markets.
Thanks, Adrian, and thanks for the opportunity this evening to come and share some details with you all, particularly with regards to one particular project that we're very, very proud of. This is a tug by the name of Sparky. You'll see it shortly. We delivered it to the ports of Auckland last September, so she is successfully operating at the moment. For anyone that doesn't know Damen Shipyards, Damen is a Dutch headquartered shipbuilder, 36 shipyards across the world, about 12,000 employees, mostly known for tugboats, it must be said. Tugboats, Damen's been a market leader for a number of years. We have, let's say, in our market here in Australia, tugs in most ports around the country. Not all, most. The tug in question, it's an electrically powered, we call it in the Damen language, it's an RSD-E 2513. The RSD stands for Reversed Stern Drive. That is a new term. It's the combination of an azimuth stern drive as well as an azimuth tractor drive. So it's a new term patented by Damen. 2513 stands for the length by the breadth. So that's how big she is. It's a project that we undertook together with the ports of Auckland, and this is probably an example of what's needed to get things like this off the ground. You can see on the slide we've got a timeline there. It's something we started discussing with them in 2014. We just delivered a conventional tug for them at that time, and then it was already questions, what about hybrid? What about what other options are there? Making different business cases. Again, at that time, the decision was made to press ahead with a conventional diesel tug, but when the time came for a second tug, you can see, do we have it on the slide? Yeah, so in 2016, the port came out with very, very publicly, the CEO stood in front of everyone and said, we will be emissions free by 2040. For the port, buying a tugboat is a 30-year investment. So they had to try and do something that would meet that goal. It took a number of years to get there. You can see we went through feasibility, concept design, and finally to get towards a contract in 2020, and we delivered last year. So the end of last year, she was awarded the International Tug and Salvage Magazine's Tug of the Year, and it made Time magazine's list of best inventions in the transport category as well. This is what she looks like. 24 meters by 24.7 by 13. Very large propellers, 3-meter props. You can see there 8 battery racks, 2,240 individual batteries. You'll see photos of some of those a little bit later on, and get an idea of the scale that's needed for those. The figure that the port, which is the owner, anticipates for CO2 reductions, that's 465 tonnes. That's based on their existing tugboat that they have with comparable power, and the amount of diesel that she uses. Probably interesting to look at how we actually got there. These tugs are not something where we can say to any customer, any port, okay, here is a tugboat off the shelf and it suits your operation. As you saw from that timeline, it took quite a while before we got, let's say, in a position to contract. And even once we realised that it was feasible, I think we were 20,000 hours engineering work in there, but before we got to contract. There was a lot that had to be done to make sure that it would suit the operational profile of the tug. You can see, you don't need to go into details on the graphics, but we were putting monitoring equipment on board the existing tug to monitor the power consumption for its daily chores, what it needed, how long it would have to recharge, to make sure that the tug could be designed around what the port needed and would be able to perform to the same level or without having to modify the existing port operations too much. Some of the other considerations that quite applicable for this port in particular in Auckland, not every port. The port already had significant electrical power installed within the port. They're running electrically powered straddle carriers. They have a fleet of electric vehicles. So there's quite a lot of electrification already in the port, which made things a little bit easier. When we look at tugboats specifically, Damen actively, following this project with the Port of Auckland, really made the decision to focus in on electrification, particularly for the vessels that we're active in. Damen Shipyards as a shipbuilder, we're not building cruise ships, we're not building container ships, we're not in bulk carriers. Let's say we're not blue water shipping. The vessels that we focus on suit the operational profile for electrification. Tugs that are working in port, ferries from A to B, other small work vessels. We looked at the available options, what's in the short term, what's in the long term, and came to the conclusion quite early on that for electrification, that everything was there. We didn't need to reinvent the wheel. We were able to team with trusted suppliers, work with them, integrate their products into our designs. We get a lot of questions, it must be said, especially here in Australia. What about hydrogen? What about hydrogen? Why aren't you building with hydrogen? Not that hydrogen is bad, but for our markets that we're working in, you can look at it very simply, and I think the graphic does show that as well. We had customers that said, okay, Damen, what about hydrogen? We want to investigate it. There's government subsidies available. Can we do something with the design? And when we start stepping through it and laying it out logically, you think, well, okay, the business case for hydrogen is based on having cheap renewable electricity to make that hydrogen. Why not put that directly into batteries? And so again, for Damen, for the vessels that we build, that we design and build, electrification is the way to go, and I think it's becoming more and more recognised within the academic world. if it can be electrified, it should be electrified, I think is the simple way that we look at it. For other applications, it's not suitable. We absolutely no one acknowledged that. How we came to building an electric tug, we didn't just start building from scratch. We always like to think you need to walk before you can run. 10 plus years ago, we started with hybrid powered tugs, various configurations, some with batteries, some without. It must be said that they were with varying degrees of success from a commercial standpoint. Technologically, they worked, but what we saw is when the government subsidies ran out, there wasn't too much benefit in them. We progressed building some small, you can see sightseeing vessels for if anyone's ever visited a Dutch canal. That's a pretty typical Dutch canal boat, slow speed. So again, very suitable for electrification. The bigger vessels that you see on the graphic, they are British Columbia, west coast of Canada, serving the islands offshore. Not electrified. They were built specific for the customer. They could see that electrification was going to be the future for them, but the infrastructure not quite there yet. So we call it built for, but not with. So those are built completely ready. There's separate engine rooms, which will be dedicated to become battery rooms once the customer gets everything installed in their ports. And at the 5-10 year docking, whenever it is, they'll be converted to electric vessels. Then we did some other. The other ferry that you can see on the graphic is a series for Copenhagen, Denmark. River ferries, again, very suitable for electrification. A to B, down the river, short hauls, dropping off passengers, picking up, charging at every stop. Very suitable for electrification. The design philosophy from Damen, again, we didn't want to reinvent the wheel. Damen's a shipbuilder. We didn't want to be developing batteries ourselves. We didn't want to be developing battery management systems ourselves. So teaming with trusted suppliers and acting as a systems integrator, being able to bring everything together, but being ultimately responsible as a single point of contact towards the customer for everything. Designed in such a way that this, let's say we call it internally, we call it the Damen-E drive, that we can use in this particular tugboat, 2513, or our bigger tugboat, a 28 metre, or a smaller one, a 23 metre, that it's scalable across the range. In terms of capacity, it was important for the port to be able to do between 3 and 4 jobs. That's what the tug was designed around. Initially, within Damen, anyhow, we didn't want to have generator sets on board. Our opinion was, we're building an electric tug; it should be electric. Why should we have generator sets on board? But our engineers are Dutch, and they think that everything is the same as Rotterdam, and all services are at your fingertips. And the customer said, "Well, actually, to dry dock, we need to steam 6 hours down the coast." So there are generator sets on board to cover for the long distance steaming, firefighting operations. You'll see some details of those a little bit shortly. Completely charged within 2 hours. That's quite important for the port. But in reality, the way that the tug is mostly going to work is it's going to do 1 job for an hour, come back for 20 minutes. 2 jobs for 2 hours, come back for an hour. And the generator sets that are on board, the port expects will probably be run once or twice a year. In terms of charging power, again, you can see it was very important for Damen to analyse the power that would be available in the port and the time that would be available for the tug to charge. So there was a lot of input needed from the port to make sure that it could suit their operations. Probably one of the big changes from a technical standpoint compared to previous tugs is the graphic there is let's say the top of the thrusters. So we changed from a traditional Z drive as a normal thruster would be. This is a L drive, so it's the permanent magnet electromotor mounted directly onto the thruster, giving we can have a higher gear ratio, and so the difference that you see on the graph there, so we have a higher gear ratio and oversized props compared to comparable tugs of this size. So what we get is it's about a 15% difference in bollard pull for the same amount of kilowatts. So it's overall it's more efficient anyway, and then you have the electric versus diesel on top of that as well. These are the batteries. So the black shoebox looking thing that you see, and to get an idea of scale, it is about the size of a shoebox. That's the one that is 2,240 of. One of, let's say, it's one of my favourite pictures, but it's not a great one as an advertisement for the environment. So it's not included in the slide. Is picture at the shipyard while all these batteries were being installed. And you really get a sense of the scale of how many of them there was because of all the packaging from the batteries. So again, so it's not a great advertisement for the environment, but the amount of styrofoam that the guys had at it was horrendous. It's a lot of batteries. As you can see there, it is a LTO battery system. That was the decision taken for combination, good performance, long lifetime, lower total cost of ownership, and lower environmental footprint. So Damen, together with the customer, we did make a comparison of the different battery types. Particular with these type is you can see there it's an expected lifetime of 30,000 cycles. So in the typical operation profile of the tug, that's going to be 30 years. And the manufacturer, Toshiba, they warranted that. So we have a warranty from the manufacturer that the batteries will perform to their set limits for 30,000 cycles. Now, that was a challenge with the customer because they say, okay, show me the battery that has lasted 30,000 cycles. Now, they don't exist. It's still new, but that's the advantage of working with, let's say, with a trusted supplier. The generator sets that are on board, it's two Caterpillar C32 1,000 kilowatt generators. As I said, they are for, let's say, we call it a range extender. So the tug sailed down from Vietnam, so did the voyage, took about 3 weeks, had an unscheduled stop in New Mir on the way, some debris in the prop, but that's another story. She's able to sail basically as a diesel electric tugboat when she's operating in that way. For bollard pull, it doesn't get the full bollard pull as it does on batteries, but with bollard pull on the generators, it can get 40 tons. So you can get 40 tons and sail at 8 to 9 knots reasonably comfortably. Generator sets are also powering the firefighting pumps. So the tug is responsible in the port as a firefighting tug, and running off the gensets, she can power the thrusters and the firefighting pump. There's still a fuel tank on board, so it can carry 40 odd cubes of fuel, so it can run not indefinitely, but as long as any firefighting operation is going to need. The generator sets also with a IMO Tier 3 compliance system on board. It's not mandatory for the customer, but you can imagine they're having an electric tug. They wanted to do everything that they could for the green credentials, so that is on board. This is how the let's say how the electric system looks. I'm the commercial guy, not the engineer, so don't ask me to explain the finer points, but it's DC switchboards with a separate port and starboard system for redundancy with 4 battery packs each side. Control system, again designed for redundancy, so it's decentralized architecture with a 3-layer design. So, how will she actually sail in operations? The vast bulk of her time is spent on batteries. So, that's sailing, 0 emissions, the power available within the port. I probably should have mentioned earlier. Advantage in New Zealand is about 80 and 90% renewable power available. The port, through its own purchase agreements, ensures that they are buying renewable power as well. So they can genuinely say she's sailing 0 emissions. While she's moored at the quayside, she's obviously charging as well. On the gensets, as I mentioned, she can do firefighting operations. She can also sail when they need to go to docking, and can use the gensets if needed. If there's a failure with the shore power station, can use the gensets to charge the batteries. The 2 systems can work together as essentially as a hybrid. So let's say the port has a big ship coming, irregular visit to the port. They have to do a long transit, a long escort, high power operations. What they can decide to do is run out on the gensets and let's say hook up to the ship on the gensets and using the batteries as a boost. That way they'll get the longest high power operation out of the tug, and they can also use, if stand closer to the microphone, if running short of time for charging, they can boost the shore power with the gensets. Doing that way can get a full charge from flat within 1 hour. This is how she looks below deck. You can obviously see the battery rooms there, a little bit different to a traditional tug. I think that picture probably doesn't do it justice. You'll see some others. It looks like there's a lot of space in there. I can assure you there is not. That's Remco, the project manager, and he's a skinny guy. It is tight in there. So that's the battery rooms. There's always questions when we're talking about batteries around safety. You can see a little bit of the ventilation ducting in there. The way that the system works is cold air entering the battery cabinets at the bottom, hot air exiting at the top, into the ventilation ducts with gas detection systems in there, as well as automatic valves increasing the ventilation power, automatic shutoffs, and if needed, automatic battery room flooding in the case of any fires. Similarly with the switchboards, another key component of the tug, temperature controlled, and similar systems as with the battery rooms. It's the pictures in the engine room. You can see the generator sets with the SCR system on board. That's the IMO Tier 3 system. It is a urea-based system that Damen developed themselves, class approved, and again, it's one developed to be able to be fitted across the range of tugs. So, for example, Damen works a lot with Caterpillar engines. A lot of the Caterpillar engines are only Tier 2 compliant, but with the system that we have Tier 3 compliance. It's the rudder propellers, as I mentioned, so that's the big difference technically compared to the let's say the old-fashioned Z drives. It's the permanent magnet motor mounted on top. What you can see off the side is the small steering motors. The other quite interesting part is the charging station. When we delivered this tug to the customer, it's not just let's say it's not just handing over the tug, it's also delivering a charging system. So Damen was responsible for, you can see the scope there, vessel connection, charging arm, and the drive cabinet. So customer responsible for delivering 690 volt AC power to the quayside. That was probably one of the challenges that we faced after delivery. It's all very well and good for us to deliver those things, but then as a Dutch company, our guys are not certified to go into the drive cabinet in New Zealand because that's high voltage stuff. So we need to rely on the customer for that. And those are, one of the small things that you learn, going through a project like this as a, let's say, as a first project. This is the charging arm. That's still at the yard in Vietnam. Simple design, and again, not trying to reinvent the wheel. So it is 4 high power automotive charging cables. You can see a small video how it works. One person, as I say, off the shelf products. There's a few safety fail safes built in. So charging obviously only starts when all cables are connected, and the vessel's propulsion can only start when all 4 are disconnected. We don't want anything starting up while they're still connected. Again, one of the let's say one of the learnings with this, you can see Remco's there connecting it while still at the yard in Vietnam, and everything worked perfectly. These are water-cooled high-power cables, and what we discovered after we delivered to the customer is that they have a larger tidal difference than we did at the yard in Vietnam. So the vessel was higher out of the water, and we had to pump up a higher head. So we actually had to upgrade the cables after delivery. Again, something you learn on a first of class project. So as we say, the future is now. It's very interesting to come and share details like this. There's a great deal of interest around tugs like this, but particularly for us here in Australia, there's, let's say, the regulatory environment needs to evolve. I'm very interested in Adrian's wife's, was it PhD thesis? What's coming on what recommendations she will be making, because we're finding it. We have a lot of interest, but everyone says, "Wow, I need some funding," or "I need this." Something has to change. Globally, I must say, after the first tug we delivered last year, Damen already made the decision to build another 5 for stock. Those 5 are already under negotiation, and they'll be sold in a pretty short time, and we'll be adding probably another 5 to the production line. So globally, the interest is there. No surprise to anyone, Australia, we're lagging a little bit, but there's some things that we can do to improve it. The business case for us, what we've seen with the port, it's been in operation for the last 3 months. The business case is better than they thought. It stacks up, but it is over. I think for the latest calculations the port made, it's going to be about an 8 to 9 year payback for them. When you look at the cost difference between conventional diesel. So the business case stacks up. We just need to help everyone to understand it. Now, let's see. Short video of what it looks like.